Okay, we've got electrolysis, and we're on part one of electrolysis, which is all about molten compounds. So first thing is, what is electrolysis? Now, electrolysis is the breakdown of an ionic compound using electricity. And what I've done here is shown you a few ionic compounds. Now, you'd have seen the first one everywhere throughout your chemistry textbooks, right? Your teachers have mentioned it a million times. That there is sodium chloride, and it's an ionic substance because sodium is a metal and chloride ions, those are non-metal ions, right? So when they come together, they make an ionic substance. Same with the one underneath it, you've got aluminium bromide. Aluminium is a metal, and bromide ions, those are non-metal ions. So they come together and they make an ionic substance. So all of those there, you'll see have metals and non-metal ions. So all of those are ionic. So those are the species we're talking about, not covalent, right? So covalent species, so things like diamond, we're not talking about those. Or methane, so CH4, that's methane there. We're not talking about those either. Or ammonia even, we're not talking about any of those. We're only talking about ionic substances. Now, the ionic substance that we choose to put under electrolysis is given a special name. It's called an electrolyte. And the electrolyte is essentially something that's going to conduct electricity. Now, we need to look at the general setup for electrolysis. So, what apparatus do we need and stuff? Generally, we're going to have a power supply. That's there, and that's there just to push electrons around in a circuit. Next, we have our electrolyte, as we mentioned, and that's our substance that's going to be undergoing electrolysis. It's either got to be molten or dissolved in water. So you'd see it sometimes as like a solution, right? Solution means it's dissolved in water. Now, for a bit of terminology, we've got this new word here. So the negative electrode is actually called the cathode, right? So that's the term you want to be using. It's a cathode. And now the cathode is connected to your power source, and it's usually made of something which is unreactive or inert, such as graphite or platinum. So why are they good? Well, graphite and platinum are unreactive or inert. They don't really react with anything. And they also conduct electricity, which is obviously what an electrode has to do. So remember that there. Your negative electrode is called your cathode. Now across the other side, you've got your positive electrode, and that's called an anode. And just like the cathode, it's got to be made of something which is inert or unreactive. And so that is also made out of graphite or platinum. Now, to help you remember those new terms, you can remember this. So the word canopy. Why remember that? Because we can say that it stands for cathodes are negative and anodes are positive electrodes. Okay, so that's just one way that you could remember it. Now, one more thing is the substance that's undergoing electrolysis. It's going to be broken into ions. There's going to be ions floating around. There are positive ions and negative ions. The positive ions, so this one over here, those are called cations. So that's also a new term maybe. I'll highlight that there. So positive ions are called cations. And now what happens during electrolysis is those positive ions, the cations, are attracted to the cathode or the negative electrode. So the cations go to the cathode. Now what happens when they get there? Well, when they get there, because they're positive, what they do is they gain electrons, okay? So they gain electrons to form the element that they are. And when they lose their charge, because they're gaining electrons, they lose their charge. And so the word for that is they discharge, okay? So cations go to the cathode and discharge by gaining electrons. Now let's look at the other side. You've got your negative ions. So negative ions, and those are called anions. So there we go, anions. And now where do they go? Well, those are attracted to the positive electrode, which is your anode. So anions go to the anode. And what happens when they go there? Well, because they're negative, they need to lose electrons, okay? So when they lose their electrons, we say they discharge as well. So there's that word again, they discharge, in order to form the element that they are. So, quick recap. You've got negative ions, which are anions, they go to the anode, and you've got positive ions, which are cations, and they go to the cathode. What do? When they get there, they discharge by either gaining electrons or losing electrons. So, Question time. What is the negative electrode called? So have a quick think. And if you can't remember, then remember this over here, right? Canopy. So cathodes are negative. So let's just go with cathode. There we go. Awesome. Now, I did mention that ionic substances need to be molten or dissolved. But why? So this is a typical ionic substance, right? It forms this lattice structure, and you've seen this throughout your textbook a million times. They have this giant ionic lattice structure, and what you can see is there are lots of forces or electrostatic forces between the oppositely charged ions. So these here are ionic bonds. They're really, really strong. So at the moment, because of those strong forces or ionic bonds, the ions cannot move, right? They're fixed in position and they're stationary. And so what this means is if we took it and tried to put it under electrolysis, nothing would happen because these ions are fixed and can't move. However, when we heat an ionic compound to its melting point, the electrostatic forces of attraction are overcome, so they break. And that means the ions are now free to move. And this happens when the ionic solid melts and becomes a liquid. So we've got this situation now, where all those bonds are now broken. And so you can see the ions now are like floating, so they're free to move around. And now because those ions are free to move, it means that this can conduct electricity. As I mentioned earlier, the positive ions are attracted to the negative electrode, which is your cathode, and the negative ions are attracted to the positive electrode, which is your anode. Great. Now, the same thing happens when you dissolve an ionic substance in water. Some of them are quite soluble in water. So when you do dissolve it, then this is what happens. Those forces or electrostatic forces are overcome again. And so you can see here that they are now free to move around. And so if you dissolve it in water, those substances can still conduct electricity. Awesome. Another question. So why do ionic substances only conduct electricity when molten or dissolved in water? So have a look through your options there real quickly. And I think we can safely say it's going to be C. Because those electrostatic forces break and the ions are free to move. Do not be confused. It's not the electrons that are free to move. Electrons are free to move only in metals, right? And things that have delocalized electrons, but those are not ionic substances. We are talking about electrostatic forces breaking and ions are free to move. That's why they conduct electricity. So now let's look at some examples. So let's say we had sodium chloride and we heated it, right? So when we heat it, those ionic bonds are going to break. So what happens is we get sodium ions and chloride ions. So we've got this. We'll have our sodium ions and chloride ions that are free to move within our beaker here, where we're doing our electrolysis. Now, we already said that the positive ions, so the cations, are attracted to the cathode. And when they go there, what do? They gain electrons to form the element. So let's take a closer look at this. We've got sodium, and that's currently in a liquid, right? It's moving around. So we've got that sodium there. And obviously the element sodium is just Na, and that's a solid. So what needs to happen to that Na plus in order to turn into Na? Well, because it's got a plus charge on it, it needs to gain one electron. So I'll put that in like that. There we go. So gaining one electron. Now, because it's gaining an electron, if you remember oil rig, hopefully you've met that before, that stands for oxidation. So oxidation is loss and reduction is gain. So because we're gaining electrons here, this process is a reduction. Okay, so what we can say is the sodium ions are reduced because they gained one electron. Now, let's have a look at what's going on the other side. You've got your chloride ions. Those are negatively charged, so those are going to be attracted to your positive electrode, your anode. Now, when they get there, what happens? They're going to lose electrons to form the element, okay? So let's take a look at that now. You've got Cl- ions, those are still liquid. And what they've got to do is go and form chlorine. But what you should note is that chlorine is special. It's diatomic. So what does this mean? Well, this means if you go and pick up a bit of chlorine and you look at it, you've actually got two chlorines joined together, right? So they hang around in pairs, like that. And chlorine as an element is a gas. It's a green gas. So we need to have it as a gas now, right? So we need to look at it a little bit closer now. What happens here? Well, we've got one chlorine on the left, but two on the right. We can't have just one of these chloride ions turning into two of these chlorine atoms, if you like. That's impossible. We need two of the chloride ions. We put a big 2 in front of here. And each of those chloride ions has a negative charge. So in order to become neutral, they've both got to lose that one extra electron that they have. So in total, they need to lose 2 electrons. So if we're losing those electrons, we're going to need to put them on this side here, on the right. There we go. So that there is our equation for what's happening to the chloride ions. Now you can see that they are losing electrons. And remember, like we said, on the other side, that's reduction. So this side, because they're losing electrons, this is known as oxidation. There we go. So you've got loss of electrons, and that is oxidation. Great. So overall, what's happened here? Well, we started off with NaCl, and that was in liquid form, because we turned it into ions. And what's happened is we've now got sodium, and we've now got chlorine gas. We can see that that equation isn't quite balanced. Now you can actually balance it from using these equations here, but that's for another time. What we're going to do is just balance it straight from here. You can see we've got one chlorine on this side, but 2 chlorines on this side. So we need to have a big 2 in front of the NaCl, and then that creates 2 sodiums on the left, so we need these 2 sodiums to be on the right as well. So now it's all balanced. Awesome. So there is our equation. Now, as mentioned already, chlorine turns into a gas, and chlorine's a green gas, right? So what we could say as a little observation is this. At your positive electrodes, your anode, you're going to see bubbles of green gas coming away from your solution. And that's the chlorine gas which is formed, so it will escape into the atmosphere, right? So make sure if you are doing this practical in school, I'm sure your teacher would put it in a fume cupboard or something like that, because you don't want to be breathing that in. Now then, you can obviously run electrolysis with a few more different compounds. Here are a few of them. We're going to look through a couple more examples. So let's look at this, zinc chloride. Now, zinc chloride, that's Zn and Cl2. If we heat it up, remember it's going to turn into ions because it's going to break those ionic bonds. So that's going to turn into Zn2+, and then you're going to get chloride ions again. But because there were 2 chlorines there was Cl2, you're going to have 2 chloride ions over there, okay? So that's the ions that we're going to get. Now, if we then put that in our beaker, this is the situation that we'll have. We'll have Zn2+ in there, and we'll have Cl- in there. The Zn2+, that's the positive ones, so the cations, those are going to be attracted to your cathode. What's going to happen? Well, remember we said, when they go to the cathode, they're going to accept electrons or gain electrons in order to form an element. So you've got Zn2+ at the moment, that's liquid, and it wants to turn into just ordinary Zn, so zinc. But how's it going to do that? Well, it's currently carrying a 2+ charge, which means it's got 2 electrons too few, if you like. So what it needs to do is gain 2 electrons. So what we do is we add in 2 electrons over there. Now, if you're unsure of where to put the electrons, what you could do is this. This is a handy way to check it. You could have a look at the charges on your left-hand side of your equation. So can you see you've got 2 pluses here and then 2 minuses here. So overall, it's neutral on that side because they cancel each other out. And then what you do is you go look at the other side and you can see there's no charge there. So that's neutral as well. And so this is good because it means your equation is balanced on both sides in terms of charge. So that's another way to check if your equation is correct. So that's what's happening there. And remember, we're gaining 2 electrons. That there is called reduction. Okay, so it's a reduction reaction because we're gaining 2 electrons. Now what's happening on the other side? Well, just like before, the chloride ions are going to be attracted to that positive electrode, to your anode. And when they get there, what are they going to do? Well, just like they did last time, they're going to form chlorine, so Cl, or Cl2 rather. So we've got Cl minuses, that's in liquid form at the moment, and it wants to turn into Cl2, which again is that green gas that we spoke about before. So we'll need 2 of these Cl minuses in order to turn into Cl2. And remember, each of those, because it's got a minus charge, it's got 1 electron too many. So what we need to do is get rid of 2 electrons, so we put 2e minus on that side. Now, remember we checked the charge before? Let's do it again. So we can check it with this. We look at the left-hand side of our equation, and you can see we've got 2 minuses there. So on the left-hand side, you've got a 2 minus charge. Now go to the right-hand side, have a look there. And on this side, you've got this Cl2 with no charge, nothing there. But then you go across and you've got your electrons, which are 2 minuses. So you can see that the left-hand side and the right-hand side are balanced because you've got 2 minuses on each side. So that is our equation. And there it is. So what's happened overall? Well, we started with ZnCl2. And then what did we do? Well, we've turned it into zinc and we've turned it into chlorine gas. And again, as an observation, you're going to see some green gas, there we go, being given off from the solution around your positive electrode there. Perfect. Here's one more. We've got calcium bromide, so CaBr2. You heat it up, what's going to happen? You know the drill, right? It's going to turn into ions. But if you're unsure with what ion is going to form, well, you can check out your periodic table. Calcium, where is it? Calcium is in group number 2, okay? And that means it's going to form a 2+ charge. So that's going to give you Ca with a 2+ charge. And bromine, just like chlorine, is in group number 7. So there it is, over there, right? Group number 7. And what that means is that carries a 1- charge. Now, there were 2 of them originally, so I'm going to put a 2 in front of there. So when we put it into our beaker to undergo electrolysis, this is what we're going to have. We're going to have lots of Ca2+ ions and Br- ions. Now, the Ca2+, where are they going to be attracted to? Well, they're cations, they're going to the cathode, the negative electrode. And what's going to happen? Well, they're like zinc. They had a 2+ charge, didn't they? So what are we going to need to do? We're going to need to add 2 electrons to it in order to just form calcium. So that would be our equation there. And because it's gaining, remember that's reduction. Have a look at the other side. Well, you've got your Br- now heading over to that positive electrode, so your anode. And remember, when they get there, they're also going to discharge. But what do? They lose electrons, right? So let's just complete this. And you've got Br-. And you've got to form bromine. Now, bromine, just like chlorine, is diatomic. So they hang around in pairs. So you're going to make Br2. Therefore, we need 2 of these Br-. And again, it's the same thing, right? Because each of those bromide ions has a minus charge, it's got 1 electron too many. So we need to lose 2 electrons in total because there are 2 Br-. Now, because this is going to be going on at quite a high temperature, bromine is usually like a brown orangey substance, liquid form actually, at room temperature. But because this is really, really warm, it's actually going to vaporize. So what you'll see is maybe some brown vapors appearing from your anode there. So I'm going to put G just to show that that's going to be given off as a gas. There we go. So overall, what's happened with this one? Well, we started with CaBr2, and then what did we turn it into? Well, we got calcium, didn't we? And we also got bromine. So there we go. That's what's happened overall. Great. One more example to go. We've got sodium oxide. So I've gone ahead and I've already broken these into the ions that they form. Sodium is in group number 1 on your periodic table. And so that means it forms a 1+ charge, as we saw before. And oxygen is in group number 6. And so that there is going to carry a 2- charge. Therefore, in our beaker, we'll have Na+ and O2-, just like that over there. The Na+, they're going to be attracted to your cathode. And what are they going to do when they get there? Well, they're going to gain 1 electron to form Na. And that's solid. There we go. And remember that there's reduction because it's gaining electrons. The oxide ions, the O2-, what are they going to do? They're attracted to the anode. And then when they get there, remember they have to lose electrons. So you've got O with a 2- charge. And what are they going to form? Well, they form oxygen. And oxygen, as you know, is a gas. But, oh no, that's not very good. Wait, let's do that again. There we go. So they form oxygen gas. But oxygen gas is also diatomic. So they hang around in pairs. It's O2. And so we need to follow that same routine again. We need a big 2 in front of this because you're going to need 2 of those oxide ions to turn into oxygen. But there's a subtle difference between this and then the bromine and the chlorine that you had before, or the bromide and chloride. Those had only minus charges. This oxygen here, or oxide ion, is carrying a 2 minus charge. So each one has 2 electrons too many. So it's going to lose 2 each. And so that means in total, we've got to put 4 electrons on that side there, right? So that's our reaction over at the anode. And there we go. So we've got that there. Oxygen, as you know, is a clear gas. So you're going to see bubbles again being given off. And what do we have going on overall? Well, we've got your sodium oxide that we started with. What did we turn it into? We turned it into sodium and oxygen gas. You can go and balance this up if you need to. So we'll put a big 2 in front of this, and then we need a 4 in front of that one there. And that should be it. Lovely. Okay. A quick question then. So what happens when ions arrive at the electrodes? So you've got option A, nothing. Option B, they lose their charge by either gaining or losing electrons, or C, they explode. So hopefully by now, with all those examples, you should know that they lose their charge by either gaining or losing electrons, and we say that they discharge. Perfect. So there it is. That's an introduction there to electrolysis. We looked at only molten compounds, and you saw that, you know, they all travel to their electrodes and do whatever they need to do to form their element. I hope you found that useful. Head on to part 2, and that is a little bit more complicated. That's where we look at aqueous solutions. So I'll catch you there.